Assalamualaikum and good day, sir. We are from group number 10. Today, Ummi, Jamal and Praveen are going to present about our assignment, Electrical Machines Case Study on Applications of Induction Machine. The title that we choose is Leaf. The types of motor that used in leaf is a squirrel cage. Why we use a squirrel cage compared to the one rotor? Okay, this is the one rotor because squirrel cage doesn't have a slip rings like this. Okay, in the one rotor it has a slip rings, but in the squirrel cage at the rotor over here it doesn't have a slip rings. Okay, so the squirrel cage can cut the cost for maintenance. Besides that, the squirrel cage has two main parts, which is stator and rotor. Okay. The stator over here is responsible for generating rotating magnetic wheel in induction motor by a three-phase alternating current. As you can see over here, this is the stator lamination. Stator laminations over here is the reason to reduce the losses, which is eddy and hysteresis current that occur during operations. For the rotor, okay, the rotor is to create a series of rotor slot. This rotor slot by composed of punch lamination stick and provide a space for the rotor winding.
Today, I will explain to you about specification of the motor elevator. That we use is three-phase squirrel cage induction motor in this lift. First, rate output power. Design value is 11 kilowatt. Rate voltage 400 voltage. Speed 1500 RPM. Number of poles 4 poles. Number of phase 3 phase. Frequency 50 Hz. Connecting install. Type of rotor squirrel cage rotor.
Next, I will explain about the operations of leaf. The most popular types of leaf is a rope leaf. So this is the image of a rope leaf. Okay, the voltage that is applied to the rope leaf is 415 volt. The main part of this motor is located at the tops of elevator shaft over here. As you can see here, over here there have control system, electric motor, and shift. Shift over here, you will see like this, but in reality, the shift is like this. This is some of components of shift like deflector shift, drive motor, and so on. In addition, I will explain about the counterweight. The counterweight is located at the end of the side slope. This is the counterweight. The functions of counterweight is to balance the weight of the car. Number 5 is a guide wheel, which guides to the counterweight to go up and down. So the problem that we can face in the lift is if the motor is lost of phase, it will causes the motor to lose some of its power and create an imbalance, which is causes an abnormal noises and vibrations. Besides that, the motor will pull more electrical currents from the remaining phases and causes a high temperatures for starting the motor. Okay, so it means that when it want to start, the motor want to start to operate, it will take a high temperature. But shouldn't have to worry when this problem happen. The hydraulic fluid in this system will cut off and lift automatically release the brake. Okay, the brake over here. This is the brake that seizes the rope for a complete stop. Okay, as you can see here, the rope, technically one rope is enough to hold up the car and the counterweight, but the other ropes is just for backup in case one of the rope is snapped.
In the modern of city skyline in this world, many buildings have lift. Before the elevating building rarely crew over 5 strong. They perform billions of rides every day around the world. Among the safest way to travel, there is less than one chance in 12 million that something will go wrong with the elevator you riding in it. The most popular elevator design is the rope elevator in this figure, where a car is raised and lowered by steel cable. The machine muscle up at the top of the elevator shaft. This one. Its rope attached to the car and loop around a shift a puller with groove to grip the rope that is connected to electric motor and turn the motor one way the elevator car goes up. But when the motor turns the other way, it goes down. That means they have two rotating, clockwise and anti-clockwise rotating. And this is counterweight elevating. Its function is on the other end of the rope to offset the weight of the car. It is usually above half the weight of fully loaded passenger elevator, so on an average ride the two a perfect balance. All the motor need to do is move the car by provide a nudge to tip the balance one way or the other. This system saves energy as wear and tear on moving parts. Once the car is moving, the motor only job is to control one of the two falling objects. Both the car and counterweight are attached to guide rail inside the shaft. They keep everything from swinging back and also give a backup set of brakes, some to grab onto.
Next, controlling part of the motor. First, temperature sensor. Temperature sensor is an electronic device, measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. Some temperature sensors require direct contact with the physical object that is being monitored, contact temperature sensors, while others indirectly measure the temperature of an object, non-contact temperature sensors. Second, speed sensors. Speed sensors are used to control the elevator motor speed. Speed sensors also use multiple technologies to detect a magnetic field change to create an electronic signal for the control system interface. These technologies offer the ability to detect speed, direction, or positions of a moving ferrous metal or magnetic target. Third, braking sensors. Sensors are commonly used near glass doors or glass store front windows. The braking sensor usually uses a microphone which monitors any noise or vibrations coming from the glass. And the last one is overloading sensor. Overloading sensor is can call as the weight sensor for sensing the weight of a load in the elevator car, a control unit connected to the center, a control unit connected to the sensor for detecting signals emitted from the sensor and thereby computing the weight of the load in the car.
And after that, I will explain about the safety in this lift, how it's work. If anything goes wrong with the motor, hydraulic fluid is cut off and that automatically release this brake that sees the rope for a quick stop. In this picture 1, this picture 2 and picture 3. Technically, one of these steel rope is enough to hold up both car and the counterweight. This steel rope, one is enough. The rest there for backup in case one snap. Okay, But what if the wall set is cut? And this picture too. Do not worry, it still will not crash because this machine has a built-in failsafe. There is governor located beside the motor with its own pulley and separate cable attached to the car. There are two spring-loaded metal hooks called flywheel inside the governor. It's a car free fall and the governor spin too fast. Centrifugal force push the hook out. What if? And this is when it snaps and the brake on this bottom of the car is automatically function. And what if free falls? In this picture 3, there are two spring-loaded metal hooks called flywheel inside the governor, and this is governor. If it's a car free fall and the governor spin too fast, centrifugal force push the hook out. This is wedge on the fixed rim and stop the puller. The governor jack on arm on top of the car and this lock the brake. And finally, the safety issue. On suggestion or recommendation on the safety issue. When we start in elevator, first thing we want to do is to take a deep breath, stay calm, find for the help button inside the elevator and push it so that will give us the communication into building engineer, where we can send an expert to come out and help. Some elevator might have a little door but those are really locked from the outside for that exact reason, so we cannot open it at the ceiling car. And also do not try to open any of the door to try to get out because we do not know when the power might turn back on and the elevator might start working. We do not want to be outside this component where we can get potentially crushed and go into danger area. Even the door not completely open, fully closed and have potential we can reach the floor of the building. That means we can get out. But do not try to get out because we don't know when it can start moving and it does. There are multiple flow that car can go between there and we don't want to get crushed or have another injured. While a safety system should start at the main entrance, elevators should be considered an effective security scheme for the building, besides being designed to ensure secure and efficient operation of the elevator. Elevator can also be combined with other building disaster and emergency systems such as civilian system, access control, communication system, fire emergency, and emergency power system. That's all. Thank you.